Okay, we're gonna be doing the Mannich reaction. We're gonna be converting into a beta-amino ketone. It's really simple. You see this is amine, and it's beta. You see it's beta to the ketone. Okay, this is how you get straight into it. Okay, these are all the steps on the right, and there's three parts. Part one, we're gonna form the aminium ion. Part two, we're gonna form the enol, and part three, we're gonna form a carbon-carbon bond. Okay, so just for the if you have an exam or whatever on this, just make sure you memorize just like the reagents for this. First step, we're gonna take CH2O. Okay, so this is really like reactive. This is an aldehyde is really reactive. So how do I write this? Damn, it's like this. Yeah, it's like this. So this is really reactive because compare if you compare it to the phenol, this is less sterically hindered, so it's gonna be really reactive. Like if you compare it to like this type of this type of aldehyde. Basically, I'm yapping. This is the most reactive like aldehyde. Whatever you could do with a different type. Honestly, I don't even know, but this is the one we used. Okay, so we're gonna have protonated amine. So amine with hydrochloric acid is gonna be protonated. So um, we're gonna activate the we're gonna activate like the carbon thing. We're gonna make it activated so it can be attacked. Okay, so we're gonna form a charge right here, and it's a delocalized charge, so we can form resonance. So just I'm gonna start using bond line now. Move pi bonds. Yeah, move pi bonds to the move electrons toward the positive charge. And so now we're gonna have right here, and now we're gonna have NH2. Basically, it's really just the exact same steps as the other questions. We're forming the aminium ion. So this is how you form the aminium ion. Two like that. He's charged, so he's gonna be protonated by himself. And we're almost there. So now what we're doing is yeah, I need to start explaining this. Okay, so now what we formed is we formed like the neutral intermediate, the amine neutral I don't know how to explain it, but it's the neutral one. Um, how many bonds is that? Okay, right here. It should have two bonds. So what's the problem? He shouldn't have an H. Okay, that's it. So this is it right here, and now we're gonna have O right here OH. So now we're gonna have to kick out OH, right? Because we have to form the medium ion. So how we're gonna do it is that OH is now the O is gonna attack he's gonna deprotonate because we're in acidic conditions. You can't form a negative charge. So right here, and so O is gonna attack it right here. Sorry, it's gonna be attacking right here. He should have an extra H. He's getting attacked because he has an extra H. Let me write it better. So he's gonna attack right here, and now we can't form an amine because this nitrogen. Honestly, these are my notes on the side. I mean, if it makes sense, it makes sense. But this is how it's supposed to be. So so now what we're forming is now this can leave on its own. So finally we formed the aminium ion. So this should be an H right here. This should be an H right here, and this should be an H right here. Now we formed is the aminium ion. So now this is the aminium ion right here. Okay, so this is the first step. Okay, just making this. Okay, this is the if you could do this, then this is honestly the easiest step. Okay, next step, part one, right? Part one. Let me put this all in like. Hopefully, I can put it all together. Yeah, let's put that there. All right, this is part one. All right, part two, right? Okay, so now what we just made is an electrophile. Okay, if you read the notes right here, this is we just made an electrophile. This is the thing that's gonna get attacked. Okay, so now we do the second part. We're gonna form the enolate. We're gonna form the not the enolate. We're not forming the enolate because we're under acidic conditions. So it's really easy. It's two steps. So the thing we have right here, we're just gonna use it, right? So it's really the same thing. It's just a little bit different when NH attacks. So first activate the carbon or the carbonyl. I don't know. Just put a positive charge on it. So we're gonna do it right now. So we have this thing, and so now it's the same thing. This is gonna get protonated. He's gonna have a positive charge. Oxygen is gonna attack it, right? So he has his lone pairs and everything. He's gonna attack right here, and now we're gonna form resonance. So, and he is going to, he's gonna have his own resonance. So basically, your whole goal in resonance is to just get the positive charge on the carbon. Okay, so now this is where it's different. Okay, it's just two steps. Before we have the NH2 attacking, before we had the NH2 like attacking that. Now it's not. Okay, we're gonna have it attack. I think this is called like an alpha, like hydrogen or something. Some crap. Honestly, no, that's a little bit disrespectful. Okay, I'm sorry, chemistry. Well, you know what I mean. Um, yeah. So the NH2, like in this example right here, if I can highlight it, like this one we had the NH2 not there. Yeah, not there. Right here. Yeah, NH2 is attacking the thing. Now the difference is he's attacking the. He's gonna form a beta eliminate. He's basically just making alkene. Okay, he's making an alkene right here. So um yeah, he's chilling. He's gonna break make a bond and then form that. So now we form the enol. Okay, that's it. We formed the enol. So this is our electrophile. This is gonna be attacking whatever we made right here. He's gonna be attacking that. So if I'm gonna highlight like our players, right? He's a player and he's a player. Okay. So now part 3 is really easy. He's just gonna attack him. Part 3, we're gonna form a carbon-carbon bond. So let's put him right here, and okay, draw our electrophile right here, and okay, he is going to attack the so delta like E rich to okay. So you see an alkene is electron rich. This carbon right here is electron poor. So we're gonna go from E rich to E poor, right there, and so now we're gonna form a carbon-carbon bond between the alpha. Is it alpha beta bond? Is basically like honestly I don't understand the terminology like that. It's just we're forming a new bond. So like if you were to number it like 1, 2. So if you 1 and 2, yeah. So then we're good here. Let me make it a little bit. I'm not erasing everything, but we're good right here. So yep, that's what happens. Um, yeah, we're obviously not done. There's like okay, so if we count our steps, right? Honestly, I don't even be remembering the steps, but what we're gonna do is we're gonna form our goal right now. Like, see, I'm not even paying attention. I don't even have my notes on me right now. I'm just trying to think about how I'll do on the exam, right? We're gonna form a beta amino ketone, right? So this obviously has to be a like if we're forming a beta amino ketone, right? This obviously is gonna have to be this. Yeah, that's honestly the answer, right? We just have to get to that. But how are we gonna do it, right? So let me see if I could like make everything smaller. I'm losing a lot of room. Yeah, I'm sorry if you just screenshot it before and honestly be alright. So yep. We're just gonna make that ketone, right? We're gonna make that ketone. So how are we gonna do it? Obviously we're gonna have to whoa, okay, this is what happened. Okay, I'm sorry. Since this attacked right here, we're gonna have protonation. Okay, it's gonna be a carbon, like a plus charge, right? Let me just even like put that in blue. It's gonna be a plus charge formed, and it's gonna be at the more stable, like the more stable place where it can be like, like think about it, right? If you do an exam, like there's only two places where the freaking plus charge can be, right? It can be here or here. Here is more like he has more. I don't know. I think it's like some type of like it's more like there's more things right here, right? One, two, three. If we put the plus charge right here, right? It's 1, 2. So that's why it would be wrong. Okay, so now what we're gonna do is we're gonna do some resonance, right? It's a freaking delocalized charge, so we can make just push electrons towards it, right? So just make the resonance for it, and we're almost at our structure, like the one that we wanted. We're almost at it. So now pick the minor, right? Major and minor. Which one are we gonna pick? I mean, you can pick whatever you want, but I'm just saying this one looks like our answer. This looks like the ketone, right? You see the answer on top. This is the answer. It low key looks like it. So we just have to deprotonate it. So what are we gonna deprotonate with? Obviously, it's gonna be with our friend NH, the amine. So bam, 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 and he's gonna deprotonate it. I don't know why I'm using this color. It's all right. Right here and done. And we're almost done. There's like two more steps, but we basically got our answer kinda. But honestly, the reaction is not done yet. Um, okay, so we're low key there, but like I don't know. This is how I was taught. Okay, so right here. So now that we formed that, we're under acidic conditions, right? Since we're under acidic conditions, this N right here, this amine is gonna get protonated. It's gonna get protonated. So since this is right here, it's going to deprotonate. It's gonna deprotonate it, right? So right here, and so yeah, so now he's gonna be protonated. And so now to deprotonate it, like now we want a neutral molecule. And so what we're gonna use is we're gonna use NaOH. So you can call it as like basification, right? So NaOH is gonna simply, you can even write basification. I mean, even put that in a new color. OH is gonna, he's gonna come and he's just gonna deprotonate it. Like I was like when I was doing this mechanism for the first time, I was like, what the hell is the point of all this? Like didn't we already get the answer? Why do we got to do all this other crap? But honestly, I don't even understand the chemical side of it. Like I understand that it being acidic is gonna end up like protonating, and then we're gonna have to make it neutral. So that makes sense. But like low key, why can't we just stop it right there? But since it's an acidic environment, I would assume that that's what happens. Like you have to do all these steps and then reform water, right? So yeah, that's really it. That's all there is to this mechanism. I hope this made sense. Just go back to like the mechanism. If right now it's super ugly. You can't really take a nice screenshot. I'm sorry. But you might have to write it on your own. I'm sorry. All right. That's it.